Good morning, class. Think everything's working? How is everybody this morning? Hopefully you're doing all right. It's a bit of a cold day today in my part of the world. They said we might get some snow today, so there you go. So, right now, Martin the cat is like seated right by the camera, so I'm just going to move the camera a little bit so that you might be able to see the fact that this cat is just sitting right here on top of the back of the couch. So that's cool. I like that. I'm going to move this way so that the cat can be quasi-frame while I give the lecture. Uh-oh. Did I kill my camera input? Please tell me I didn't kill my camera input. Maybe it just reset. Well, thankfully I was looking at it when it did it this time. Yeah, it's so silly. There we go. Yeah, he's cute. We'll just let him sit there. So, there. Okay. There. Cool. We can have cat lecture today. I'll try not to block the view of the cat. A little tired. How am I? Yeah, a little tired as well, I guess. Yeah. Yeah, he's a poofy guy. Aw. Yeah. He's actually not... Like, a lot of it is just puff, you know? But, yeah. Best time of day, yes. Well, you know, whoop, you don't want to fall off there. Be careful. Be careful, kitten. Yeah. Anyway. So, we should get to our lecture today, eh? Right. So, the last time we were talking about exceptions and exception handling. So just to review briefly, exceptions are definitely a thing that you've seen before in Python. The Python exceptions that you're dealing with, that we're learning how to handle right now, are the same exceptions that have, you know, probably caused you no end of frustration as you've been doing the assignments and the tests and all of that stuff. So now we're learning how to handle these types of things. Oh, he's so sweet. So, at the end of class last time, we talked about the try-except block. So, just to review quickly, try-except operates reasonably similarly to an if-else block, in that you're describing two different branches of execution within the overall flow of the program. The difference, however, whereas a if statement is provided a Boolean condition which dictates the manner in which the branches are executed, in the case of a try-except block, whether the try branch is executed or the except branch is executed is determined by whether or not an exception is raised by some piece of code inside of the try block. As soon as an exception is raised, pardon me, Python looks at any except clauses that have been attached to that try block, and if there is an except, there we go, see you, Bubs. If there is an except block that matches the particular error that was given, the code that is inside of the block represented by that except clause is executed. So I was demonstrating yesterday that the way that it works is the try block executes code until it hits the error, and then it immediately jumps to the except clause without executing the rest of the try block. And, we were also demonstrating that you can have multiple except clauses, which accept any of the different native error types that exist within Python, and maybe even a few others, as we're going to see when we get into classes. And, if you want to catch all error types, just leave this blank. But it's important to note that these except clauses are traced through in order. So if you put the blank one at the top, it'll catch the error at that level, and basically you'll never hit the zero division error. Oh, what have I done? Oh, it even gives, pardon me, it gives you a syntax error if you try that. So it says, oh, you're trying to do something that's not legal. So the last one of these can be the catch-all, but if you put the catch-all before that, it'll complain at you and tell you you've made a syntax error. I'm used to C where they let you get away with stuff like that. Time change sucks. The condenser mic isn't on. Okay. Thank you. Yep. Like, I'm so glad I got the condenser mic. The difference. There really is a considerable difference. There's a considerable difference between the condenser mic and like any other microphone. Even though this is not a particularly expensive condenser mic, it's like I don't know what type it is. It's like there's a label on it, but I can never read it because the symbol is just kind of weird. But yeah, I think it makes a big difference in the listenability of these lectures. So, yep, I'm pretty happy. I got it on sale for like $99 with the arm and everything. It was pretty awesome. But anyway, what was I talking about? I got distracted by my microphone again. Yeah, okay. So, yep, we've already talked about that. Okay. So here's an interesting one, right? So far, we've been talking about raising exceptions. We've been talking about handling exceptions. But did you know that you, the programmer, can also produce exceptions whenever you like? We have a new keyword. That keyword is raise. If you raise an error, it does the exact same thing as if you were to, quote-unquote, hit that error naturally. In fact, any time that you hit an error naturally, essentially, you've hit a raise error statement somewhere inside of all of the Python code that is inside Python that makes Python work that you don't necessarily see. So if we have our interpreter open, we can raise a value error, and you can see it raises a value error. Ta-da! If you want to raise an index error, then it raises an index error. If you wish to raise a Smurf error, in case there are Smurfs, you don't get to do that because Smurf error is not a defined error type. However, we're going to see how we can define our own error types as soon as we're finished with these slides, actually. That's the first bit of classes. Because, since this is object-oriented programming, everything is an object, including exceptions. So, we'll see. We'll be able to manipulate the underlying structure of Python itself. We will transform ourselves from apprentice, the sorcerer's apprentice to Archmagi. Anyway, so here basically the rest of this lecture is a bunch of like a listing of the common types of exceptions that you'll find inside of Python programs. So you've got the index error. That's when you're trying to access something that's outside of the bounds of a list or a tuple or a string. So, L is equal to 1, 2, 3, and you try L at 6,421. That's an index error. A type error is when you're trying to perform an operation on things that operation isn't defined for. So, for example, if we try to add 3 to a list, that's a type error. Can only concatenate list, not int, to a list. So, the plus associates itself with L, right? It associates itself with the list type. So whatever it gets as the second argument to that operation, it's expecting something that's compatible with a concatenation operation. So you can see, if you reverse it, put the 3 first, unsupported operand type for plus, int, and list. That's a different type of error. That's the type of error you get when you're trying to add two things together, plus interpreted as add, as opposed to plus interpreted as concatenation. And of course, the fix for that is to put 3 inside of its own little list there. But, there you go. Value errors are applied when a function or an operator is applied to an object of the right type, but in some way it's otherwise inappropriate. So you can kind of think of type errors as being a more specific subclass of value errors. Value errors are a more general type of error. So, for example, going back to our previous example, if you have an empty list, L is an empty list, and you try to take the max of L, you get a value error. Arg is an empty sequence. So you cannot, it doesn't make any sense to take the maximum of of something that's empty. Another way that value errors are sometimes phrased is as domain errors. And you guys who are like in the mathematics stream, you guys who are taking math degrees should be, you'll get this, I think, because you guys are more interested in like abstract functions and that kind of thing. So functions have a domain of applicability, right? If you think about logarithms, if you think about logarithms, there's nothing like logarithm is not defined for negative numbers, right? So like if you import math, log of negative 40 is math.log, value error, math domain error. So if you're trying to apply something that's outside of the domain of applicability for a function, another way, like if I was in a more computer science-y type, to phrase that in terms of computer science terminology, you would say the required preconditions have not been met for that function, right? Preconditions are the things which we say are true about the input to a function, right? Postconditions are things we say are true about the output of a function. So if the input that you receive is not commensurate with the input you require, it is the correct course of action to raise a value error, which is very similar to a domain error inside of mathematics. In some programming languages, they'll just call it a domain error. Those will typically be the more mathy languages. But anyway, let me check to see if we have any questions. Can accept only check for errors? Or could you also check for conditions? Like accept x is greater than 5 or something like that. Ah! Well, that's interesting, because that's actually going to be our last slide. So I'll leave that, I'll put a pin in that one, and we'll come back to it, okay? When would you need to raise an error? So this is a good question because it's often the kind of question that I like to throw into tests and exams, you know, raising a particular error. You know how up to this point we've been putting stuff in test questions like, if this calculation would fail, then return false instead? Well, now we're going to be saying things like, if the preconditions aren't met, raise a value error. So we might say, you know, this function is applicable to the natural numbers, and if you receive something that's not a natural number, raise a value error. That would mean that if you would have to check to see if it was a float, or you'd have to check to see if it was negative, or a string or whatever. And in any of those cases, you would raise a value error. Except in order to distinguish from like regular value errors that might occur, we often ask you to produce a custom error, a customized error type, as we're going to see how to generate again in the early part of the slide 6. Slide 8, pardon me. Will a question specify situations in which we need to raise an error, or do you have to come up with those yourselves? In general, we'll tell you what errors we want, because, again, we want to make sure that you're doing the question instead of just like if you just raise an error and that error happens to be, you know, if we ask you for an error that a person might produce by writing terrible code, then we can't tell, like the autograder can't tell if it was an intentional, you know, intentionally you did the right thing in the question, or this person just borked up their solution, but they still hit the test case anyway. So we often ask for custom error types. But yeah, raising error is totally a thing. So, to answer your question, when could you check for conditions? Okay, no, let me do one more slide and then we'll get to it, okay? So, quickly, not implemented error. You probably have seen quite a few of these inside of the assignments. That's just a placeholder error when a function has not been implemented. This is usually more valuable when you're working on a big project with other people. It's like you can put all of the function prototypes in so that, you know, the interface is well defined without having yet implemented what's supposed to go inside of those functions. This is kind of Python's way of doing C-style function prototypes, which is something that will only make sense to like a handful of you, but there you go. Recursion error. We've seen those before. When maximum recursion depth is exceeded, you get a recursion error. Runtime error. When some error occurred that isn't classified elsewhere. So these are pretty rare. It's pretty rare for you to hit an error that's like not any one of these defined errors, so you probably don't have to worry about that one too much. Zero division error occurs when somebody tries to divide by 0. Again, doesn't make any sense within the context of computing. Some languages handle zero division by having like spoofing an infinity value, but obviously it's impossible for a computer to hold infinity inside of it since it's not a finite entity. So these things typically cause division errors. That's one of the advantages of like having your a human brain, which is capable of higher levels of abstraction than a computer, because a human being has never killed themselves over over thinking about the concept of infinity. Well, maybe that's not true. Well, anyway. At least not in a mathematical sense. In a philosophical sense, I won't make the assertion that nobody's killed themselves over the concept of infinity. But certainly in a mathematical sense, I don't think anybody has ever died of the infinity symbol in mathematics. So, assertions. So your esteemed colleague raises an interesting idea, which is, what if we wanted to check for a particular condition being true? Well, it's possible to raise an error based on a Boolean condition, and it's kind of shorthand for, if condition C raise error. It's basically this. It's shorthand for this construction. But all we have to do is say assert 1 is equal to 1, or so that's just kind of like my, this is a obviously true condition. With assert statements, if the condition is true, execution passes by the assert statement without having affected anything. However, if the condition is false, it raises an assertion error. So this is a mechanism by which you can check to see if a particular condition has, you can use this to check preconditions, you can use this to check post conditions, but sort of fundamentally, it is definitely a shorthand for if condition raise error. The only thing is, you don't get to control what type of error is raised. It's always going to be an assertion error. You don't have that level of control over it. So if you need to raise a particular type of error, you still need to use the if statement construction. But if it doesn't matter what type of error it is, an assertion error, if an assertion error is good enough, then you can use an assert statement. So yeah, that is topic 7. Thank you very much. Let's move right along to topic 8. So, I'll just give you guys a moment to ask any questions you might have about topic 7 before we move on to topic 8. Okay. I think we can be reasonably assured that nobody's raising any questions. It's reasonably straightforward. As topics go, topic 7 is reasonably straightforward. There's really only 3 new constructs to learn, right? Try, accept, raise, and assert. So, so, insofar as Martin is the chonker among the cats in my house, this topic is the chonker among the topics in this class. Classes are something that typically people have a reasonable degree of difficulty understanding. So we're going to go through it slowly. Well, we're going to go through it at a decent pace, because we have to keep the pace up somewhat. But we're definitely going to take a little more time for questions, and you guys probably will have questions about that. So, fundamentally, if you're... Okay, please listen to the next 30 seconds to a minute, because this is the framing for, the hardest questions that I'm going to ask you on tests and the exam in this course. Okay? A class is a way of packaging variables and functions together. You take variables, you take functions, you compose them into one entity, and that's a class. All right? It's a group of variables plus a group of functions. within the context of a class, we call functions methods, and we call variables attributes. Sometimes we, because basically right now what we're talking about is object-oriented programming, writ large. And, depending on what programming language you're using, the terminology is going to be slightly different. So, if you're talking in a C++ context, you would be talking about member functions and member variables. If you're talking in a Python context, you talk about attributes and... Actually, I'm not sure what they... I'm not sure if it is methods. Let me just skip ahead a little bit. I need the exact terminology here. Methods. Okay. They do call them methods. Okay. Methods is good enough. So, the important thing to know here about classes is that fundamentally, at a fundamental level, it's not a million miles away from all of the concepts that you've taken in so far in the course. You guys already know what variables are and how to work with them. You guys already know what functions are and how to work with them. We're going to teach you what classes are, how to create them, and then we're going to, apply that. So let's take an example. You can raise exceptions. So going back to the previous set of slides, raising exceptions. If your code enters a situation that that isn't intended to handle or doesn't want to for some reason, you raise an error. Sure. There are a bunch of different types of errors, which we just talked about. But what if the type of error you wish to raise is not already predefined? What do? Let's say the computer is just lazy and doesn't want to do the work because it's lazy. How do we create a lazy error? Well, method number 1 is you can actually raise a general... you can raise an exception of a general type with a customized error message. As we're going to see, exceptions are a class, and this creates an instance of that class. So this is one of the sort of sticking points with respect to classes. There's a difference between the class and the object, right? Objects are instantiated. They behave to a great extent like variables or the aggregate data types that we've already been working with. Pardon me. Like lists. So, you've already been using objects. You've already been using classes and objects. You just didn't know it. When you have a list, right? Let's say list, 5, 4, 6, 7, right? Or equals. And you do L.sorted, or sort, and then L becomes sorted. Have you ever wondered why we're using the dot here instead of using it like a function? It's because the sort method, it's a method, is defined for the class that represents lists. So this allows sort to be defined, it allows it to be specific to lists, right? So basically what we're addressing here is, there's kind of a hint of an implication in the previous lecture that, like, if a function is not capable of taking x, y, and z inputs, then you should raise an error, right? What methods allow you to do is kind of restrict a function to a particular set of variables, right? So if you were to, if you had a string, well, it might work for strings, actually, but string.sort, does that work? No. So strings don't have a sort function. So you don't have to worry that the sort function doesn't apply to strings and raise a value error inside of it, right? It's just simply not defined. And notice it's an attribute error, which means that there's no method called sort defined for strings. But anyway, let's see. Let me see if I haven't confused people completely. Is using exceptions and raising errors a way to make things more user-friendly? Well, kind of yes and no. It makes your programming more rigorous and more correct. But that doesn't necessarily mean it's easier to use. Obviously, if you put more errors into your code, there's more possibility of raising errors. And if you view the raising of errors as being something that frustrates a programmer, it's like, oh, I've got all of these errors, then you're not improving the user experience in that sense, but you are improving the rigorousness of the code itself, right? The code is more correct. Like, there's a trade-off between the code being correct and the code being, like, malleable enough to forgive small errors, I guess you could say. And generally speaking, Python as a language errs much more on the side of forgiving small errors than it does being sort of rigorous. That's the motivating philosophy behind the dynamic typing, which I always complain about. Like and subscribe. So if you wanted to raise an exception with a custom error type, it turns out that you can invoke the class itself, pass it a string, and it'll raise a general exception with that string attached. So, too lazy. Exception, too lazy. Right? So this is suboptimal because you can't do except matching over the returned string, right? It has to be this guy that's matched by the except case, not these guys, right? So how do we do that? You create a new class. So this is our first class. Class lazy error inherits from exception. We're going to talk about what inheritance means. And we'll just make the content, make it empty right now. So what inheritance means is I want to include everything that's already in a specified class. I just want, I want it to have a new name. So we can now raise lazy errors. Right? Main.lazyError. This just means that the class has been defined within main. That is to say, within your program, as opposed to the Python prelude or the libraries. So now that means we can try raise lazy error except lazy error print sorry, too lazy. There you go. Notice like, we can now use that exception name to do exception matching the same way we would with a value error or an index error. And the reason that we can do that is because the manner in which those things work is encapsulated in the definition of exception. Cool. So, let's see if I haven't lost everybody. Nope, okay. So, are there any more questions about that before we move on to the next example? Give me a thumbs up if you're following. Thumbs up. Chat's pretty tired today. Everybody's tired. Okay, we got one thumbs up. One guy is currently watching. 2, 3, up, there we go. Excellent. All right. Out of a class of 50, 10% ain't bad. So, number 2. Let's talk about data policies. So, with respect to this particular graphic, what's going on here is we're going to talk about a genealogy chart for a very popular fantasy novel series. So, yeah, we're going to define a custom data type that allows us to enforce data policies. So, if you imagine the manner in which you would describe a genealogy chart in this sort of sense, using everything that we've covered up to this point in the course, you would probably use something like dictionaries, right? You would have a field for the name, a field for the children, which points to a list of, possibly other dictionaries that have been defined. These would be pointers. These would be aliases to previously defined dictionaries, as we talked about previously, and we would have a field for spouse. So, in general, we're interested in 3 fields. We can have a whole series of dictionaries which have all of these 3 fields. In some sense, this is similar to the idea of the dictionary of dictionaries question that caused everybody so much consternation on a previous assignment. You have a bunch of dictionaries that are all formatted in the same way with the same labels so that, with the same keys, so that you can rely on consistency between the keys so you can access the data more easily. This is the establishment of a data policy. However, here's a question. What if somebody makes a mistake, right? What if while generating all of these dictionaries, the person who's doing so forgets to specify a children field, or forgets to specify a name field? If the code that you're writing relies on the existence of these keys within this set of dictionaries, if it hits a key that doesn't exist, it's going to raise an exception, and that exception is going to crash your program unless it's been handled. And you wouldn't expect it, so it would probably crash the program. So, so we can do better than this, essentially. Let's see. The convention was that every person represented by a dictionary. Yep. What if in... Yes. And misspellings can also be a thing, right? So, you know, if you misspelled one of these tags, it would cause the same problem and be less obvious. The other thing is, a dictionary is a dictionary is a dictionary. So we can't actually tell, by using the type function, what the purpose of the dictionary is. We also can't attach any help, like we can't attach any doc strings to just a dictionary to give the user some kind of idea what the bloody thing's for in the first place. They'd have to read the code, use the source loop, and that's never a good idea. Alright, am I back? Alright. Hello. Testing, testing. That's... I thoroughly apologize for that. So while I was disconnected, I did all of this example, and that's I think I lost like 10 minutes. How long was I out, guys? Jeez, I did lose about 10 minutes. Irritating. Okay. I determined the cause as well. My Ethernet cable somehow became detached from my computer, which meant I was popped onto the Wi-Fi, which reset OBS, and OBS couldn't establish a stable connection because it was on Wi-Fi, and... bleh. Oof. My most humble and sincere apologies, folks. Great. Oh well. Well, are there any questions about, like, the material that I covered before everything cut out? What a pain. And you guys correctly observed that it did occur at the worst possible time, because, like, this is actually important stuff. Ugh, how demoralizing. You know, under normal circumstances, it already feels enough like I'm talking at a brick wall, you know? God almighty, do I miss being in person lectures. Oh yeah, no, like, it would be the picture of cruelty for my stream to cut out, and then me just not cover the stuff that I talked about in the stream. You may consider this. Well, actually, I didn't move in the slides in all that time. I was just doing an example, but I'll redo the example when we resume on Thursday. No, I can't. It's not possible. I don't have enough local storage to be able to record these. Like, I rely on YouTube doing the recording for me because I don't have enough storage on my really ridiculous 6-year-old laptop that I'm still using to be able to record these lectures as I'm giving them using OBS. So I don't record the lectures. YouTube records the lectures for me. So unfortunately, those 10 minutes are lost to history. They will never be recovered, unfortunately. So... All right. Well, I guess class is dismissed, folks. We'll resume on Thursday. We'll go back over the stuff that, you know, didn't exist. Believe it or not, this type of thing was happening pretty much every lecture before I got my internet fixed last semester. So consider yourselves fortunate that this is the first time this has happened. Anyway, have a good rest of your Tuesday, folks. I'm gonna get me some lunch.